All right, guys, so for this video, we're going to be talking about graphing the parent square root function with a horizontal translation. Okay, so what that means is our graph is going to shift either to the left or to the right, depending on the number that is with the square root of x. Now, for the horizontal translation, the number is with the variable underneath the radicand. Remember, on the vertical translation, the number was outside. This one is inside the radicand. It's with the variable, with the x. Okay, so that means we're going to move it left or right. Okay, so this one is a little bit tricky because if you see here, we see y equals the square root of x plus 3. Okay, so when you see plus 3, it's actually the opposite. Like when we had it outside, if it was plus 3, we would have gone up 3. If it was like minus 4, we would go down 4. Okay, with horizontal translations, it is the opposite. Okay, and in a little bit, I'll show you why. Okay, and the second thing is the effect of things on our table of values is basically we're keeping the same y value. Okay, we're going to have y equals 1, y equals 2, y equals 3, and it's going to change the x value, this number of spaces. Okay, so simply we'll just graph this thing just like we did with the vertical translation, except for in this case, it's going to move our x. Okay, so in this case, it's going to move our x 3 spaces to the left. So 1, 2, 3. Okay, so our y is still at 0, but our x is taking on negative 3. So that's going to make negative 3, 0. Okay, our y is 1, and when y is 1, x is 1 minus 3 is negative 2. So negative 2 and 1. So we go negative 2 up 1. Okay, when our y is 2, our x is going to be 3 to the left of that. So we see we're just shifting it left 3, 1, 2, 3. Okay, that's going to be at positive 1. Okay, so 2 on the y, positive 1 on the x, so 1, 1, 2. So we just took this one here, we moved left 3, 1, 2, 3. Graph the function. Okay, and then the last one we had when y was 3, x is 3 less than that, so it's going to be x equals 6. So 1, 2, 3, 4, 5, 6, 1, 2, 3. Or we can just take it from here and move left 3, 1, 2, 3. Okay, so when we go to graph this line, okay, we see we have the same line. Basically, eventually, this thing would actually probably cross it. So I'm not drawing this very well. But you get the idea. Okay, so it's the same line. It's just shifted 3 spaces to the left. If we had it, if it was minus underneath here, it would be shifted to the right, that many spaces. Okay, so if we did this math, and it's the opposite here, so I'm not going to try to do plugging in values of x. Well, let's do that real quick, actually, but we'll show you what we're trying to do here is get this to be the perfect square. Okay, so what value of x makes my y equal 1? Okay, so in other words, we have 1 equals square root of x plus 3. Well, what makes that true? Okay, so it could be, oh, I'm sorry, I did 1, I should have done 0, my fault, 0. So I should have done 0 here. So what makes this true? So x has to equal negative 3 for this to be true. Equals square root of negative 3 plus 3. So 0 equals 0. That makes, so it's the negative 3 that makes that true. And it's going to be the same for each one. We'll do one more. Okay, so we'll do that one I was trying to do before. 1 equals the square root of x plus 3. Well, what value of x is going to make that true? Well, the square root, what gives us the square root of 1? The square root of 1 gives us 1, I should say. So it would take a value of negative 2 to make this true. So 1 equals the square root of 1. So 1 equals 1. Okay, so that's what makes it true. But the way to do this quickly is to just look at the number next to the x, make sure it's under the radicand. If it's under the radicand, we know it's a horizontal translation, going to move to the left or to the right. If it's plus, we're going to move to the left. If it's negative, we're going to move to the right.